Hello and welcome to another video in this series looking at how to achieve structural steel design using AI and retrieval augmented generation. In this video, we will watch Claude Opus 4.7 design a composite steel concrete floor system. On the right, we have Claude doing its thing, working away diligently on a structural steel design. It's sped up so you can see the full 21-minute one-shot design without any human intervention. On the left, we'll take a look at the report Claude generated and compare the design with the AISC Steel Construction Manual design examples. This is example I2 from the manual, which designs a composite steel floor girder. We'll see that Claude gets nearly exactly the same results as in the design examples, with both determining a girder size of W24x76. Claude specifies 48 steel-headed stud anchors between the supports and the point of maximum moment, and forgot to add the minimum 3 anchors in the constant moment zone. The manual specifies 52 stud anchors plus 3 in the constant moment zone for a total of 55. The capacities and deflections during construction and during the composite stage are nearly exactly the same. However, Claude slightly overpredicted the construction capacity due to a small calculation error, 708 kips compared with 677 kips. So I flick through this quickly, but of course you can pause it whenever you wish to see more details. The report begins with an executive summary. Then the framing geometry, material properties, and applied loads are established. The interior girder's tributary loading is determined and the unfactored point loads from the slab, secondary beam self-weight, construction live load, miscellaneous dead load, and assembly occupancy live load are tabulated, and the LRFD factored design moments for both the pre-composite construction stage and the final composite stage are then calculated. Next, a W24x76 is selected as the trial section, and the pre-composite check on the bare steel section is then performed, considering inelastic lateral torsional buckling with the top flange braced by the secondary beams, followed by the construction stage shear check. Following this, the composite section flexural strength is calculated, and the minimum permitted degree of composite action is checked. Next, the steel-headed stud anchors are designed. Acceptance checks on stud diameter, height-to-diameter ratio, projection above the deck, and concrete cover are performed first. Then the nominal stud shear strength is calculated and the required number of studs is determined for the chosen degree of composite action. The stud spacing and layout are then checked. Then the serviceability checks are undertaken. The pre-composite construction deflection of the bare steel section is calculated, the live load deflection of the composite section is calculated, and the total post-camber deflection is checked against the L/240 limit. The report is finalized with the final design specification, a capacity demand summary table, design notes for review and construction, and references. Set up your free structural steel design RAG to use with any AI LLM model. Step 1. Download the free RAG vector databases from steelcoldform.com. Step 2. Follow the instructions on the engineering RAG page to set up the API for running queries. Step 3. Connect your LLM of choice to your RAG API, allowing your AI agent to query your RAG as required. RAGDBs were created from free PDFs of the specification provided by AISI, AIC, and ANSI. All RAGDBs are provided free to promote the use of steel.